new strategy. Actually, it's the 4 partial products investigations. Part of it would be done a little bit differently if we were in class, but we are not in class. You were stuck at home, and I am here alone, wishing you were here because I'd much rather be teaching. If you could all jot down the title, what we're working on today: 4 partial products. That name, partial products, should ring a bell from last year, but we're just introducing it a little bit differently this year. It's kind of interesting, though. But math is interesting, as we all know. Copy down this problem: 35 times 23. Now, kind of like we did with division, we're going to introduce partial products also with an area model. And kind of like what we did with division, we are going to introduce or start by writing down our dimensions. And we'll put down our first dimension on the left. Doesn't have to be a certain length, but my first dimension is going to be 23, so I'll put down the 20 first, followed by 3 dashes to represent the 3. That's our left dimension. The top dimension, you may want to take a guess what that is. That's right, Jojo. It's 30 and 1, 2, 3, 4, 5. 35. Then we're going to draw a rectangle to show our whole product. Kind of inside of our dimensions. I guess it's the opposite of outlining, we're inlining. Then we're going to draw 2 lines to show how the product can be divided into the 4 partial products. I'm going to give you a few seconds just to look at that and think about that. How could I divide this rectangle into 4 parts to show the 4 partial products? So if you think about partial products, that might help you make a little bit more sense of that. So our first partial product is 20 times 30, sorry. So there's 1. And then we also have 3 times 30. 1, 2. We also have 20 times 5 and 3 times 5. So those are the 4 areas of our products, our 4 partial products. I want you to keep taking a look at that and see if your array looks similar to that. Compare your results with your neighbor if you're working with someone. If not, talk to your mom and dad about it or give me a call. Then let's see if we can figure out what each section is going to equal. What's the product of each part of the array? And I'm going to do something similar to partial products right here, 35 times 23. Who can tell us what the first product of 20 times 30 is? Correct, Harper. 600. 20 times 30 is 600. And I'm going to draw a line from the 2 to the 3 so I know what I just did. Now, if you could guess right now or make a logical guess, a good estimate about how big is our answer going to be. It's going to be at least 600 or more because our largest place values are 600. And then we'll just continue to multiply all of our products together. If you want, you can even write 600 in here so you can see it. Then we're going to multiply 20 times 5. Draw my line. Some of you might be remembering what you might have called it in 4th grade if you had Mrs. Spencer, I believe, the bow tie method. 20 times 5, or 25s, is 100. Now we're done with our 20 on the bottom. And then we're going to multiply our 3 and our 30. So I'll draw another line from the 30 to the 3. And that equals, correct, 90. Jot down my 100 over here just so we can see it. And then we have 3 times 5, which equals, correct, Kai, 15. Good job. And yes, I do talk to myself or myself, when I'm here all along, since nobody else is here. Just imagine everybody here, just like I imagine you folks with your hands in the air volunteering. Then we add all four of our partial products together, and we get 805. Now, if you were so gracious enough to open up your bridge book, if you have it, if not, I'll attach it so you can work on it, at least see the problems. This is the problem that we just did, 35 times 23, so you don't have to do that again because we just completed it. But what you're going to do today is complete the rest of this page, A, B, C, and D. And then flip it over and see if you can solve the number stories before Friday. If you can't get it done by Friday, you can work on it this weekend. But there will be another assignment tomorrow. So how about we at least try to do 2A. But back over to the other side. We'll get you started. And if you want, we can do A together. And if you want to draw the area model, you may. You do not have to. But our first dimension would be 20 and 1, 2, 3, 4, 5, 6, 7. Like this. Move my sheet up. Our second dimension is 43. So we have 40 and 1, 2, 3. Then if you have all kinds of different colors laying around, you can inline your area model, make a rectangle. And then we're going to work on splitting it into 4 parts. So I first have my 20 times 40. And we have our 20 times 3, 7 times 40, and 7 times 3. 43 times 27. 20 times 40 is 800. Now you notice I'm doing it slightly different than I did the first time. You can include the problem over here if you want. You don't need to, but if you need a visual, it's a great thing to do. So we know that our product is going to be more than 800. It will be at least 800. Then we'll take our 20 times 3, draw our lines if you want. 20 times 3 is 60. Then we're down to our 40 times 7, which is 280. Followed by 7 times 3, which is 21. Then if we add these all up, our partial products, we should get our product correctly. Add the 1s, 0 plus 0 plus 0 plus 1 is 1. 8 plus 2 is 10, plus 6 is 16. Regroup our tens digit. 8 plus 2 plus 1 is 11. 1,161. So your goal for today, finish B, C, and D. And if you're feeling really energetic or bored silly because you miss me so much and you miss my amazing math lessons, you can work on to A, B, and C, or at least try to get A done. Hope everything's going well. Again, don't hesitate to call. Send me a text, Google Hangout. I hope to touch base with everybody soon. Stay well, stay healthy, and be happy.